Kinematics is an important concept. It means measurement. Kinematics means measurement. Kinematics means measurement. Kinematics means measurement. I said it 3 times because if you've heard something 3 times, supposedly that's supposed to be part of your permanent memory. How did kinematics arise? Probably the astronomers noted the motion of the stars, and they began to track it and to make up charts which would predict in the future where the stars would appear in the sky. So these circles became associated with measurements, and from that we could interpret mathematical relationships. The acceleration of the stars must equal their speed squared over r. That's a consequence of the measurement. Galileo made measurements of a falling object, and he found that the speed of an object is proportional to the time, no matter what the weight of the object was. So he can generate from that a algebraic equation, a mathematical description of free fall, but all of this is based on measurement. They're not applying any laws except using the measurements to generate the laws. So this is a process of induction. The law of the pendulum, same thing. You observe a pendulum swing, measure its period, and knowing the length and the acceleration of gravity, you can calculate the period. So the law is generated from measurements. Now, an important concept here is relative motion is valid. In kinematics, if I were 5 feet north of you, then you would have to be 5 feet south of me. That's an example of relative position. Repeat that with velocities, accelerations, and so on. And you find that measurements always obey relativity. So relativity is true for measurements. Or we could say observer reference frame independence. Kinematics is arguing from specific to general, and it measures the quantity of motion. And that's why mathematics is applied, because all you get from a measurement is a number, and you have to use that number to predict things in the future.